Sorry, I have no idea why that cut out like that did, but that gives us the negative 33 over 20 all over the 56 over 20, which is going to equal the negative 33 all over 56. Moving on, example 5. I feel alive with example 5. So this one, it actually looks incredibly scary at the beginning. And this used to be, and this again was a question that showed up on the diploma. So please make sure that you guys sort of pay attention on how to do this. I know it looks scary at first, but we're just going to write out what we have here, and we're just going to write out what we have right there. So in my first one, I get, well, that cos A plus B is going to be cos A cos B minus sine A sine B, and we know that is going to equal 0.8320. Subsequently, the cos A minus B is cos A cos B plus sine A sine B, and that equals 0.4358. Now we're looking for cos A cos B, and we notice that since we have right here the negative sine A sine B, why is my red not working? The negative sine A sine B and the positive sine A sine B, that if I add these two equations, that piece will cancel out. So adding these two equations gives me 2 cos A cos B equals 1.2678, which will leave me, when I divide both sides by 2, with cos A cos B equals 0.6339. Now finally, we're going to solve this equation over this domain. This one is pretty funky, but again we notice sine A cos B minus cos A sine B. So that's just going to tell me that this equals the sine of 5x minus 3x, which would equal the sine of 2x, and we know that this equals 1 from my statement above. So, if we use our unit circle, that would give us that 2x equals pi by 2, or 5 pi by 2. Why? Because sine x equals 1 at pi by 2, or 5 pi by 2, but I have that 2x on the inside, so instead of just the sine x, we're going to have the 2x. Then, to complete my solution, I just divide by 2, which will give me pi by 4 and 5 pi by 4. Okay, I hope you guys have enjoyed, and I apologize about the technical difficulties I've had through these lessons.